Hey, what's up? It is time again. You know what time it is? It is 9:41, April 15th, 2021. April is halfway done, almost halfway done. Or it's halfway done. And things are looking pretty spring-like right now. And with that being said, I've decided to play for you some Rachmaninoff and also do for you a coding problem. Alright, and this is the nightly work that we do to get you sharper, and to get me sharper, and to get all of us sharper in the world of CS, and whipping out those competitive coding problems like there's no one's business. So, with that being said, let's work on our skills with this problem, maximum number of balloons. Alright, and as the music intensifies, you get to really think about the maximum number of balloons, a very lofty indicator, way better than minimum. So, problem 1189, maximum number of balloons. Given a string text, you want to use the characters of text to form as many instances of the word balloon as possible. You can use each character in text at most once. Return the maximum number of instances that can be formed. Okay, so, by the way, so this problem is fairly well liked. It's 524 likes to 48 dislikes. It's probably because it's a short problem. I like those short problems that have some depth to them. I really don't like reading long problems with lots of like extra words in them, even if most of the words don't actually mean anything, because I don't know, it just feels more fun to actually do the coding and more educational to get to the coding, especially when the solution could be something more involved, even for a short problem like this. So, the examples are, I have NLAE Nale Bolko, input text equals Nale Bolko, and the output is 1. That means that balloon can be extracted, the word balloon can be extracted once from Nale Bolko. Okay? Then you have Loon Ballex Ballpoon. Okay. And you can extract 2 balloons from Loon Ballex Ballpoon. Say that 18 times fast. Yeah. Okay. And finally, you have lead code, and there are 0 balloons you can extract from lead code because you're missing some important characters like B and A, and for that matter, an L. Okay. So how do we solve this? So let's think about it, right? There's probably some brute force techniques you can think of, right? Like just look for all the B's, look for the number of B's that occur, the number of A's that occur, the A's that occur, the L's that occur, the O's that occur, you know, and yeah, that's one way to do it. And I mean, but let's try to do this in a way that's a little computer sciencey, right? We want to take advantage of a data structure with some nice lookup properties, right? Whenever I think of these character problems, I feel like I want to do that. Okay, so one thing I want to do, I'm thinking that I want to create a map. Okay, firstly, I want to look at balloon, and I want to look at the map of my string. This is off the top of my head, and then I want to extract do the character count by comparing both maps and their values. All right, so let's start with since we need a map of words, right? It's convenient to have a little mapify function. So let's get that started. Character integer mapify string, and I bothered to turn this into a function because it shows good functional programming chops, and I might use this more than once, right? I might convert more than one word, so why not just turn it into modular piece. Okay, so this is my count. So for int I equals 0, I less than text.length. Yes, this is my weeknights frantically coding to classical music. Don't you wish you were me? No. Map.put text I get or default, my favorite map function. Text and car at I 0 plus 1. Okay, so basically this is just taking my map, whatever it may be, creating an empty one, and just taking the input text and adding the character and its count one by one to the map by looking at the count of the character that existed in the map, or defaulting to 0, otherwise I'm just adding +1 to that. So that's pretty much the function, that my helper. Now to the main code. So first thing I want to do, as the music gets so intense I can barely hear myself screaming, I want to I'll explain why I put this minimum here in a minute, but let's create my maps, okay? Let's see what maps I'm gonna need. I feel like I'm in the Pirates of the Caribbean movie right now. And, okay, so obviously I want the map of my word balloon. Now this could be any generic word, right? Like, they made this easy, very easy by saying it was just balloon, but you could mapify anything if you think of a practical use case for this, which, of course, there are practical use cases for something like this. So, I'm gonna call this text map. Okay. So, for now is where I'm gonna do my my map comparison. So, pay close attention to the birdie. That key set. Okay. So I'm going to loop through my balloon map, and then I'm gonna check. Right. This is not too complicated. I'm gonna check whether the characters in my word map, the characters in my balloon map are contained within my text map. Right? And if they are, what I want to do is, this is where the trick of it is. Min. This is, and I'll explain in a second why I have min. You'll see it. Get C. Text map. Get C divided by a balloon map. Get C. Okay, so that's like why am I doing this? Okay, well, firstly, right, you would think that it would just be a simple count at first, but that's not necessarily true, because you have to make sure. Look at the words that the input word for balloon map. It's the word balloon, which contains 2 L's and 2 O's, right? So basically, for every character, if you would, under normal circumstances where there wasn't a repetition of characters, if the character is simply contained within the map of the input word for every single character, then that should be sufficient to say that I can add 1 to my number of words that I can create, right? Or number of instances of balloon that I can create. But balloon has 2 L's and 2 O's. That means I have to make sure that the total number of words, or the total number of characters, and the total number of L's is actually a factor of 2, and the total number of O's are actually a factor of 2, right? And so what's the easy way to do that? So just divide by the total number of instances of the characters, because that's always going to give me, if I have only one B I'm looking at, that means that balloon map get B will be equal to 1, and that divided by the total number of times that I can get the number of balloons. So for example, if I have word B, so for example, if I have BBBB starting off, just starting like that for now, I'm going to have start off with 3, because there's 3 instances of B in my text map, divided by 1, because B only occurs once in balloon map. Okay, now why is it minimum? Because minimum I mean, if I have BB and then I have A, then I can definitely craft 3 B. Just if I get up to this point, I can craft 3 balloons. But at this point, I see that I only have 2 A's, so at most I can craft 2 balloons, right? And so, therefore, I have to reduce the number of balloons I can craft. So that's why I'm taking the minimum between the two. Uh, between the existing minimum versus the total number of characters I have divided by the characters I need. Okay, if that makes sense. And in this case, the answer will be 1, right? Up to this point, because I have 3 B's, so at first I would think I would have 3 balloons, but then I have 2 A's, then I would go down to 2 balloons, because that's the minimum, and then I would have 2 L's, and because there's 2 L's, and the minimum check requires you divide your character presence by the number of instances in balloon of the particular character L in this case, then at that point in time, that's how many I know I can have. So that's going to be 2, because in text map there's 2, and in balloon map there's 2, so that equals 1. So the minimum is 1, okay, for this example so far. So you should be getting it by now. I don't think it's rocket science per se. And then at that point, else, so if we don't get the existence of the character in in text map of one of the characters in balloon map, then at that point we can just kill it, because we can't get any balloon maps. And then finally, at the end of the iteration, we get what min is so far. So let's see if this works. Missing return. Oh, oops. It was in the for loop. Let's try this again. So for loon ball x ball poon, that's 2. Let's try submitting it. And there you go. Not the fastest game in town, but also not too bad, because we passed. And that was the important thing. Space was fairly better, almost better than 48% of those others who are competing against me for the best algorithm here. Okay, well, so that's it. And I think that was an interesting use of HashMaps. Pretty common one. And yeah, if you like this video, like, subscribe, comment in the space below, and let me know what I'm doing right versus wrong, and just continue to code, and I shall see you later. Have a good night.